Water, essential for life, flows through intricate systems designed to deliver clean and safe drinking water to millions. But hidden within these systems lurks a hidden threat: biofilms. Biofilms are complex microbial communities that adhere to surfaces submerged in water. These communities, composed of bacteria, fungi, algae, and protozoa, thrive in diverse aquatic environments. Biofilm formation begins when microorganisms attach to surfaces and form microcolonies. As these microcolonies grow, they produce an extracellular polymeric substance, or EPS, cementing the biofilm and shielding it from environmental stresses. Factors like temperature, pH, nutrient availability, and water flow rate significantly influence biofilm growth. Stagnant water and nutrient-rich environments also promote biofilm development. Biofilm formation can have a significant implication on water quality. Biofilms act as reservoirs for pathogenic microorganisms, evading traditional disinfection methods like chlorination. They can clog pipes and filtration systems, reducing water flow efficiency and compromising infrastructure integrity. Biofilms can also accelerate corrosion in water distribution systems, releasing heavy metals and other contaminants into the water supply, posing serious health risks. To combat these challenges, effective biofilm management strategies are essential. Regular cleaning and maintenance are crucial to prevent biofilm buildup. Mechanical removal disrupts their structure and reduces contamination risks. Disinfection techniques like chlorination are vital but must be adapted to combat biofilm resilience. Innovative surface modifications, resistant to biofilm attachment, enhance cleaning effectiveness and prevent biofilm formation. Advanced monitoring and testing technologies, such as the Kraken platform by Kraken Sense, can detect biofilm-related microorganisms promptly, which enables proactive intervention. By implementing these strategies, we can manage biofilm impacts, ensuring clean and safe water for all.